problem here. This is one of questions question bank. Uh, so let's discuss this one here. Test for convergence. Consider this part A. Let's consider that part. Right. So want to check whether this infinite series is convergent or divergent, right? So here you have n factorial square divided by 2n factorial, right? So if you see this one, right? So look at this one here. So what is, when you simplify this, 2ncn, which is same with 2n factorial divided by n factorial times n factorial. So therefore this one is 1 over 2ncn, right? So and there's another one. So we know binomial expansion, right? So let's consider binomial expansion of 1 plus 1, which 1 plus 1 to the 2n, right? Which is same with 2 to the 2n, right? Which is same with 4 to the n, right? When you consider this binomial expansion of this one, right? You know this, right? Sum goes k goes from 0 to 2n, and 2n ck 1 to the power 2n times 1 to the power k, which is equal to 1, right? So you can see that this one here, this one is one of terms of this finite series, right? So therefore the whole series, the whole finite series, is greater than or equal to 2ncn, right? So we can, let's move this forward a little bit. So 4 to the n greater than or equal to which one? Let's simplify this. This one here. Which one? 2n factorial divided by n factorial whole square, right? Alright. So, and clearly we know that 5 to the n is greater than or equal to 4 to the n, which is greater than or equal to this thing. And when you simplify this, let's cross multiply this factorial n squared and 5 to the n and factorial squared divided by 2n factorial, which is greater than or equal to 1. Then here you can see that here same thing. So all terms in this series is greater than or equal to 1. All terms in that series is greater than or equal to 1. That means let's say this one is equal to a sub n, right? A sub n. So the limit of a n is not this limit of a n does not converge to 0. We know that if the series is convergent, right, this one goes to 0 as n tends to infinity. But here it doesn't go to 0, as n tends to infinity, because all terms, all ans are greater than or equal to 1. This is true for all n greater than or belongs to n. Yeah, that means this series, infinite series, is divergent. That means that infinite series, say I, that infinite series is divergent or divergent, right? So that was question number 1. If you consider the other problem B, right? Here you have n factorial squared times 4 to the n divided by 2n factorial. Right? Same thing. Right? Here we showed that 4 to the n greater than or equal to this thing. Then, right, as before, we can show that all terms in this series are greater than or equal to 1. The limit of part B, the limit, so let's sum an if this term does not converge to 0 as n goes to infinity. We can say that this infinite series is divergent, right?